You've got your design document. Go ahead and make sure that it's up here by the end. But today we're starting the next module, Module 3. There is a video series and a book chapter on this for reading and watching. But of course, we'll be looking at it with slightly different examples, maybe from the book or from those pre-existing videos. But we're going to start with SQL, and then we'll talk about database design and creating tables later on. But I wanted to start with a really quick motivating example here, because this is basically a flat file. This is what you were working with, let's say last semester or even this semester on your first assignment, where you did you did a video game report. It was a flattened file. In other words, it had like platforms and games and publishers and this complex data model that was flattened out into one table. And of course, that's not sufficient. With even this simple flat file where we've got some course data, right? The course, the number, the name, the student that's enrolled in it, their NUID, and their email, there's still lots of problems here. What's one problem with this data, with this flattened data? What do you see immediately? Lots of what? Okay, null, right? If there's missing data, sometimes it's represented as an empty string. Sometimes there's this flag value here, none. Sometimes null, right? Maybe the course name should never be null, right? There's no way to enforce that kind of integrity with a flat file. What else is going on? Yeah. Inconsistencies, right? These are called data anomalies. Because the name is stored in different places multiple different times, in other words, repetition, then there is a potential for an anomaly, right? Student, comma, John, John student, student, comma, J, right? All of those are the same people according to their NUID, but they have their name represented in different ways in different parts of the flat file. And that's because we've got repetition of data. Anything else? What do you see? Tom has two emails, so maybe that's okay though, right? But what happens when we go in and try to update the email? Oh, he's got a new email, so we create a brand new record with none, 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 but then an email record here, right? That seems like extremely brittle, right? Or what if he updates his email? Which email do you want to delete? Which one don't you want to delete? Not only that, but even just finding one record means that you have to process every single row to find those records. So instead of getting just the fine data that you want, you get you're forced to do to process the entire file, like you were forced to process the entire file on assignment 1, right? We had records in there with a publisher but no games, just so that you in the report you had to report this publisher had 0 games, right? It seems like a flat file is not the way to go on that, and you found that out when you were trying to do assignment 1. Right? So again, a repetition of data. There are formatting issues. If there's a number, right, that number is represented as a string in a CSV file in a flat file. There's no way to enforce that, and so there's a whole can of worms if you use CSV files or flat files. There are consistency issues. There are integrity issues. There's no way to enforce any rules because everything is a string. Right? There's also organization problems. It's not sorted. It's in one big file. So if you've got a program coming in and it's doing one report on the data, then it puts a file lock on it, and it means that there's no another process can't come in and look at that data, right? Or change that data. So everything becomes a serial operation instead of that parallelization that we looked at on Tuesday. And there's, of course, no security. Right? If you have access to the file, read or write access, then you can do anything that you want with it. You can't say that, oh, you can have access to this stuff over here, but not that stuff over there because it's in one big giant file. The solution is an RDBMS, a relational database management system. Of course, there are lots of RDBMSs. Off the top of my head, MySQL, you'll be using MySQL. You'll actually be using MariaDB on CSE, which is a MySQL clone. There's a SQL Server, MSSQL, Postgres. That's a true open source software one. Oracle, IBM has DB2 and Informix, right? Does anybody know of any others? SQLite has been mentioned before, which is basically a MySQL implementation stripped down for embedded systems. Any others? No? Okay. Anyway, it goes back all the way to 1970. Edgar Cod. Later on, when we look at normalization, there are 3 rules to normalization: that everything in a table has to depend on the key, the whole key, and nothing but the key, so help me Cod. Right? And that's from Edgar Cod, the inventor of relational database management systems back when he was at IBM in 1970s. I don't know that he actually gets credit for SQL itself. I think that that's somebody else, but he came up with the idea of storing stuff using relational models. In 235, have you got to relations yet? No? Oh, but you've got to sets, right? So what yes? No?
Yes.
Oh.
Some people, yes.
Some people, yes? Okay. What is this? That's a cross product, right? Or also called a join. That's something we'll get to by the end of today, right? Take everything in this set and match it up with everything in this set over here, right? If you put a further constraint on it, then you've got a relation, a mathematical relation. A mathematical relation is nothing more than a subset of the full cross product, right? So people who said that they've not gotten to sets yet, can you read this? No, not yet? Okay. All right. All right. You'll get to it eventually, hopefully. All right. So one of the key aspects is that data is still stored in tables, but that's the operative word right there. Tables, not just one big giant table. Data is stored in columns. You do have fields, and you have rows, which correspond to records. So you can think of one table kind of like an Excel file. But much more powerful with rules that you can actually put on it. Excel, you can go ahead and type whatever the hell you want, right? But in a database, you define what the columns are, and then you can insert records, which are the rows. Each row may have a unique identifier, which is called a primary key, or PK for short. And all well-designed databases are going to have those, and the database example that we're going to look at today will as well. Rows between tables. So if I've got a table here and a table here, and I've got records that have some sort of a relationship between each other, I define that relationship with a foreign key, or an FK for short. Right? You can interact, and the way that we're going to start this out is by just jumping right into it with a tutorial. We're going to interact with a RDBMS, MySQL on CSE, MariaDB on CSE, with basic CRUD. CRUD is create, retrieve, update, and destroy. Right? And the keywords in SQL are going to be insert, select, update, and delete. Right? Now, note here that I am only going to cover generic SQL. All of those SQL vendors that I talked about before, SQL Server, MySQL, Oracle, DB2, etc., they're all going to have their different dialects. I forget what they're called. I think SQL Servers is called Transact SQL, which is TSQL. I forget what the other dialects are, but basically they take basic SQL and then they add their own features on top of it because they want you to use their database. So they want, and if you use those features in your code and you become dependent on those features, you have what's called vendor lock. Right? It's way more expensive to rewrite all of our stuff and switch over to a free product like Postgres than it is to stick with Microsoft and keep paying for SQL Server over and over again. Right? I'm only going to cover the generic SQL that will work on pretty much any SQL server or any database server, relational database server that you're going to use. Okay. To do that, we're going to look at something familiar. Look familiar? Right, this is what you had in homework 1, and I think we also used this last semester as well. It's my go-to database because I designed it specifically for instructional purposes. It's well designed, but it's got a lot of gotchas that are good teachable moments here. We've got a video game database with a game table, a platform table, so games, Animal Crossing is coming out soon, right? So Animal Crossing, and it's available on what platform? Switch, right? And nothing else probably ever, right? It's exclusive, okay. And then you've got publishers, and I assume Nintendo published it, or will be publishing it, right? And we've got this table in between here that a game is available on a platform. Animal Crossing is available on Switch, right? So what kind of relationships are there between these two tables? Between these tables, that's where this diagram comes in. This is an ER diagram, an entity relation diagram. This is a one to then this chicken foot here is a many diagram. That one publisher can publish several games. Nintendo has Animal Crossings, Super Mario Brothers, blah blah blah, whatever else you can think of for Switch. But one game only has one publisher. Now, in the real life, you might have a game that has multiple publishers or developers or something like that. That's not what we're modeling here, though. What about between the game and the platform table here? We've got one to many and then a many to one. That means that there's a many-to-many relationship between these two tables. One game can be available on many platforms, and of course, one platform can have many games. Within each table, if you take a look at game ID, there's this little key there. That is indicating that it's a primary key. Right? That's why there's a key there. Right? And the name of the game. By the way, game ID is what type is it? It's an integer. Right? It's a number. And it's going to be unique. This game has game ID 1. And no other game has the ID 1. This game has game ID 2, and that's unique, right? You'll never have two games with the same auto-generated ID. Key management is a very difficult problem that is easily solved with an RDBMS. So we're going to let it do its job. Okay. We've got a name here with a var char. What do you think that stands for? Var is variable. Char is character. So variable number of characters up to 255 characters. There's generally a limit. In some sense, there's also a practical limit. You can't. I think that in MySQL, you can have at most 2 gigs of text data, and then you're out because that's the largest addressable. But this is we can shorten this up to 255 at most. There's a historic reason for why all of these are 255. Why? That's one less than 256, and 256 is 1 byte. All right. So efficient addressing. But as long as we don't have any game with a title that is more than 255 characters, we can store that data in this database. If we do have a game that's more than 250 characters, what's going to happen is data truncation. It's only going to store the first 255. Right? Then this is also an integer. It's a publisher ID. That's the relationship up to the publisher table. You can look at this as a parent-child relationship. That a child cannot exist without the parent, but a parent can exist without the child. We have a publisher. We can have a publisher that has not yet published any games, but we can't have a game that doesn't have a publisher because it's a child record. Right? Look at this from above. We've got a publisher and then a child down here, like many children. It can have many children. And the way that we achieve that is through a foreign key. The publisher ID is an integer that is going to map back to this primary key up in this other table right here. Right? Likewise, these are foreign keys. This little red diamond that indicates a foreign key in an entity relation diagram. And this one refers back up to this table, and the second one refers back up to this table. Okay? All right. Given that, let's go ahead and get started and start doing some CRUD. Right? Create, retrieve, update, and destroy. To do that, I posted yesterday or a couple days ago that to get started, you might want to download MySQL Workbench. Some people have said that they've had trouble on Windows. Any Windows users have trouble in here? Okay. It's cross-platform. The price is right. It's free. It is owned and put out by Oracle, so trust it. If you don't like Oracle, then don't use it. But you're gonna have to find something else. PHP MyAdmin is installed on the CSE server if you want to use that. Otherwise, I used to use Aqua Data Studio, but that's because somebody else paid the license on it. You can use Eclipse, you can use IntelliJ, and there are a bunch of plugins that you can use for those. But I'm just going to use MySQL Workbench because it's so convenient and easy. It's convenient, right? SQL. I'm going to go ahead and launch it over here, right? And that's what it looks like when you start. Now, to get access to your database, you do not have to install a server. If you want to, you can go ahead and play with your own server and be your own admin, be your own root if you want to. But otherwise, as I said on the post, you need to go ahead and go into AMU, the Account Information Portal, or whatever they call it. There we go. Hopefully that's my login. There we go. And if you go over to Account Settings, you can set up email forwarding if you want. Hopefully this looks the same for students. But you can click right here to reset your MySQL password. Now when you get your password, you can change it. I linked to the FAQ on how to change it. But do not use a password that you use for any other system. Eventually that password is going to end up in your code, and TALAs and myself are going to see it. If you've teamed up with somebody, you might be sharing that password, so don't choose anything secure. Right? With that password, it should not be the same as your CSE password or any other password that you've used. With that password, somebody can just exploit your database, but that's pretty much it, so who cares? Right? If you want to follow along, I've already committed that database that I just showed you, along with a bunch of test data to the GitHub repo for this course. It's in the spring 2020 notes where everything has been pushed. Everybody's aware of that, right? Okay. And you can go ahead and go to videogames.sql. Go ahead and get the raw, and I'm going to go ahead and cut and paste that, and we'll set up my database here now. Okay. First of all, when you want to connect, you can go up to Connect to Database. And it might look a little bit different if it's a new link or something like that. You will be connecting to csc.unl.edu. Same server as usual. Don't touch the port. That's the standard port for MySQL. You are not root. I am not root. Okay. Why aren't there more memes with root and groot? But okay. But anyway, use your username, and then of course connect. I've already set this up. I recommend that you don't store, well, you can store the password if you want. I never store my passwords. There we go. There. Say what? What do you name the connection? Whatever you want to name it. Oh. CSE is what I named mine, I think. Right? And if everything worked, you're in. Right? Now, if you were root, you could create any database with any name that you want. Unfortunately, you only have one database with one name, and it matches your login. If you want to use that database, you need to use and then whatever your login. Don't use my login because you're not going to have permissions to do that. You're going to have to put your login there. Right? What I'm going to do is I'm going to actually wipe away my database because I was using it in the previous class. I'll drop database, Seabrook. I'll execute that, and then I'll create it again. Create database. And now it's been created. See down here, these little green things? That means everything was great. So basically, I deleted my database and everything that was in it, and then I recreated it. What's in it now? Well, let's use it and see. I'm using my database. Show me the tables. And there are no tables because I have not created any yet. Okay. Now, this is what it's going to look like when you first log in and start using your database. MySQL Workbench, if you want to execute one command, for Mac it's going to be Command Enter. If you want to execute the entire script that you've written here, that's going to be Shift Command Enter, and that executes everything all at once. You can also do it by the buttons up here. Windows, I'm not sure what the quick keys are, so you're going to have to explore that. I'm sure that it's probably Control Enter and Shift Control Enter or some such like that. Okay. So I have no tables. So what I'm going to do is I'm going to go ahead and cut and paste this entire script. Of course, changing this from your login to my login, and I'm going to run the entire thing. Right? And it worked. Right? Nothing but green down here. Okay. So let's go ahead and clear this out. And then we can start doing basic CRUD on this database. This database has now been created, and I've got a bunch of records in there as well. Okay. So CRUD, right? Create, retrieve, update, and destroy. Let's create some games. Right. Create some records using an insert query. Right. All right. By the way, what am I doing here? In general, use lower casing for SQL. This is the modern convention. Right? Insert into game, and then we'll get to it in a second here, the rest of it. But and it's complaining that there's a syntax error here because I've not completed this query yet. But what are these two things right here? What do you think? It's ignoring them, so they are comments, right? Now, universally, hyphen space is probably going to work on all database systems if you cross your fingers correctly. Sometimes you can use a hash or some combination thereof. Sometimes hyphen is enough, but for MySQL, it's got to be hyphen space. You can also sometimes use multi-line comments. This is a multi-line comment. Right? And generally they'll be ignored, but it depends on the database. Something that seems to be universal though is hyphen space. So I'll go ahead and go with that for this one. Okay. In general though, use lower camel casing for SQL. You could do something like this. Insert into game, values, values. Give me a game. Super Smash. Isn't it Bros or Brothers? Bros? I don't know. Is there a consensus? Which one is it? All right, I'm going to go with Brothers first, and then we're going to change it later. Right? Super Smash Brothers. Right? So this is the old school way of doing it. You will see a lot of tutorials that put uppercase on all of the keywords in MySQL. That's because back in 1970, when COD and everybody else was creating this stuff, there were no color monitors. You had green screen monitors, or at least monochromatic monitors. And so, of course, to offset things, all the keywords were uppercase, all the table names and everything else was lower underscore casing, so that you could clearly delineate which one was which, and it would really pop out and be obvious. We no longer live in the 1970s, right? We have nice syntax highlighting where certain things are in blue, right, and bold. The table names are going to be black. Strings look like this gold color. There's green for backticks. I think you can backtick. Oh, red. Oh, that's nice. I like that magenta. But we have color coding now, right? There is no reason to kill your pinky finger anymore. The entire time I was typing this, I was holding down the shift key. Right? So save your pinky. Right? Use the modern convention. Use lower camel casing for SQL. This is the modern convention. Right? So insert into game, values, Super Smash Brothers. And another thing to realize is in the first instance, I was using double quotes. In the second instance, I was using single quotes. Just like PHP, it's either or as long as you are matching them at the ends. Okay. Generally, you want to stick with one or the other, though. I'll stick with double quotes. Okay. That's how we can insert a new record. Before I go running this query, though, what's one thing I should probably think about? Maybe I already put this game in there, right? What would happen if I have two games called Super Smash Brothers? Super Smash Twins. Do we want that to happen? Okay. If we don't want that to happen, then we should design our database that way. We should say that only the name on your games has to be unique. And I don't know if that rule is something that we should do. There's Super Smash Brothers on Wii U. Right? There's Super Smash Brothers on Switch. Oh, they do? Oh, okay. All right. So maybe this is a design discussion. You go back and forth and say, should we enforce uniqueness on this or not? And you can build it into your database later on when we start talking about how to design tables. But for now, I'm going to check to see, is this game already in there? And this is a preview of the R of CRUD, retrieve. I'm going to select everything from the game table. Let's see what's actually in there. So we've got GTA 1, 2, 3, and 4, Legend of Zelda, Super Mario Brothers, not Super Smash Brothers, a bunch of good old classic games, right? When games used to be good, right? They're not good anymore. I think I don't have anything since 2011 in here, but we can insert something. All right, so you said Super Smash Brothers. I didn't see it there, so there's no problem with inserting that record. Uh-oh. That's not what I want. I want to expand you. Give this more room. All right, well, we're not going to... I can't increase the size here, but column count doesn't match values. Oh, sorry. Insert into game name values. Now let's try that. There we go. Now that's the error code that I wanted. So the syntax here is insert into the table name, and then in parentheses, all the columns that you want to specify. For the game table, oh, this is game ID. That's going to be auto taken care of for us by the database. So we don't need to specify that. We can if we want, but again, key management is something that the database takes care of. Let it do its job. The name, we've specified that as a variable character. One thing that we're missing, though, is a publisher ID. And that's what this error is about. Cannot add or update a child row, foreign key constraint fails. Again, can a game exist without a publisher? Nope. It'd be like a child existing without a parent, just ex nihilo coming in, being created from nothing. Right? So what we need to do is we need to specify both of those things, publisher ID and Super Smash Brothers. But the problem is, what's the publisher ID of Nintendo? I don't know. Let's find out. Let's select everything from publisher. So I see it. It's already created. Right? So publisher ID 5. I can go ahead and hard code that, and that will work. Right? Let me go ahead and execute that. There. Green down below means everything's good. If I select everything out of the game again, then Super Smash Brothers with a publisher ID of 5 and that auto-generated ID of 22. I don't know why it skipped 21, but that's its business. It could randomly assign values, but this is clearly going in like increments, and then it'll wrap back around and use anything that's been deleted. So again, key management is its job. Let's go ahead and let it do its job. You can, think, I can do a better job of key management. I can do something like this. Game ID, name, publisher, and I could put in a 101, right? Right? What's the risk there? Let me go ahead and go to the next line. What's the risk on this? What if there's already a game with an ID of 101? Is it going to work? In fact, let's find out. I'm sure that there's a game in there already with an ID of 1. Red. Duplicate entry 1 for the primary key. Again, it's a key. It's unique. It's universally unique. No other game can have an ID of 1. Let's see, what was that game? GTA 4. Looks like. So we can't do that. So we can choose, 100. Right? That's certainly way out there, but again, and that'll work. But again, key management, let's let it do its job and take care of it for us. So let's go ahead and run, or we already ran this now twice. Let me go ahead and show you another way of doing this. Instead of hard coding that foreign key value there, meaning that you'd have to look it up, what's the key value, pull the key value out, and use it, you can go ahead and use insert into game, and I'm going to cut and paste a lot of this. There we go. And then I'm going to have a subquery here. This is called a nested query. What I want is I want the publisher ID of the publisher named Nintendo. So select publisher ID from publisher, where, this is our first where clause, we'll talk about it in more detail later on, where name is equal to Nintendo. There we go. And I should be consistent about it with double quotes. All right, there. And that one will also work. You see green down below. At this point, however, how many Super Smash Bros. Records do I have? 3. Right? I probably don't want that many. Right? And again, you can go back to the drawing board and say, no, we're going to have unique names here. In which case, it would have failed to do this. Okay? But all right, let's go ahead and get rid of those. So the D of CRUD is destroy. You can delete record. You can destroy or remove records in a table from a table using the delete query. So I want to delete those 2 duplicate game records that I just put in there. Delete from game. Okay. Unqualified like that? What do you think that means? Delete from game. Everything. Right? So, okay. Absent-mindedly, go ahead and run this. It's not going to let me. Maybe read that down there. You are using safe update mode, and you tried to update a table without a where clause that used blah, 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 blah. In other words, I tried to do something very dangerous. That something very dangerous is to delete every single record, period. Right? And I'm in safe mode. Thankfully, it saved me from myself, so it's not going to let me do that. What I want to do is I want to delete just those 2 duplicate records, this record and this record. I'll go ahead and keep the first record. Okay? I want to delete where the game ID is 100 and 101. So delete from game where game ID is equal to 100. All right, there we go. And I can do it again with game ID 101 because that was the other duplicate record. And both of those are going to be green. That's perfectly fine to do that. And the duplicate records are now gone. Okay? The where clause means that you're only doing it for a particular record or a group of records or something like that. If you just have an unqualified delete from game, that means that you want to delete everything. And if you do actually want to do that, fine, go ahead. There is a query that you can shut off safe mode and then run whatever query you want. Right? But thankfully, the default here is that it's not going to let me do that. Okay? All right, so that was the U. Oh, no, sorry. That was the C and the U, or C and the D. Now let's do the U. So again, that Super Smash Brothers, we should rename that. We should rename that to Bros, right? Something like that. Now, the nice thing about using an IDE like this is that you can do something like that, and it will actually, if you hit save up here, it'll actually generate the SQL for you to do that and actually interact with the database and do it. You can, TIE fighters, right? I could do something like that. Now, it's not saved until I hit some, I think it's, no, that's add, that's remove, refresh data existing usually. So if I just refresh this, oh, did it actually persist? Oh no, I didn't want that. Oh, there. Before, do you want to save your changes or not? Don't apply that. All right. And if we see this, okay, it's still the same. But you can go ahead and add manual records using an IDE like this. All right. What I want to do though is I want to change it. I want to update it. U is equal to the update and update. You can change column values of existing records using the update query. That's the only one that matches CRUD. Create, retrieve, update, and destroy. We've got select or off the top of it, dang it. Insert, select, update, and delete. Update is the only one that actually matches the CRUD value. Right? Okay. You can change the column values using the update query. Update, game, set name equal to, we want that as Super Smash Bros instead. Right? Also, another note, I'm ending everything with a semicolon. That's usual. You can change that. You can reconfigure that. But it's almost universal that it's going to be semicolon. Okay. You can have as many queries as you want. And you can run them all in a batch query or run them individually. What's going to happen here? Update game set name equal to Super Smash Brothers. Did I say which record to touch though? No. So once again, you are using safe mode. You tried to do something that's going to affect every record in the table. You don't want every game to be named Super Smash Brothers, do you? Nope. So we need to put in a where clause where game ID is equal to, does anybody remember what it was? 22? Okay, good, very good memory. But let's go ahead and use a nested query instead, where select game ID from game where title, or not title, name is equal to, if I were actually designing this database, by the way, I would have used title instead, but I'm using name so that we can play with it later on, using aliases and a bunch of other things, where name is equal to Super Smash Brothers. There we go. And execute that. And let's look at all the games again. And you see that it is, oops, what was wrong? Come on, execute. All right, what? Game is specified twice. Oops. Game from game where name is equal to update game set name equal to where game ID is equal to select game ID from game where name. I don't see what's wrong. Set name equal to Super Smash Brothers. Like this, you mean? Yeah, that would be me setting it up. Update game set name equal to where game ID. Well, let's go ahead and go with 22. This should be okay. There we go. This should be okay. All right. And that was successful. Okay. I don't know why it wasn't working, but I can't see it immediately. So I'll put that as a question mark for later on. Okay. Don't want to save. All right. So that's why I started with create, update, and destroy, because those three are pretty much straightforward. They all have one particular use case and only one particular use case. But select, pulling data out of the database, that has 1,000,001 ways of doing it. Because you can actually do data crunching on the database end itself. So as we were looking at before, you can select everything. All right, so the retrieve. In general, you use the select. You can retrieve elements from the database using the select query. Right? And you can select every column using the wildcard, which is what I was doing before, the star. So select everything from game. That means I'm going to get all three of those columns. If I did it with the publisher, I would get both of those columns. If I did it with the availability, I would get all four of those columns. But maybe I don't want that. Maybe I want to be more judicious. Right? Maybe I only want the name of the game. Right? So I can select, you can specify particular columns to retrieve instead. Right? So select the name from game. Maybe also you want the publisher ID. I don't know. Name. Let's go with this for now. Select name from game, and you only get one column with the names. Okay. Oops. What if you want multiple columns? Select the name, comma, publisher ID from game. And you get two columns. You can, of course, select them all and enumerate them all. You can change their order, right? You can put the publisher ID first, and then the name. The order generally doesn't matter, though, right? Because what does it matter that this column comes before this column? It's just data, right? What really matters is the rows corresponding to that 6 corresponds to GTA 2. Right? That's the publisher ID. Okay. Why would you want to only select certain columns out of a database? Eventually what's going to happen, in fact, what's happening here, this database is not on my computer. It's sitting over on the CSE server right next door. Say that it was sitting on a server halfway around the world through Amazon Web Services or something, AWS. It's expensive to send stuff over the wire, right? So if I select, it has 10 columns, and I select all that data, even though I'm only going to use one column, guess what? All that data is going to be transmitted. Whereas if I just said, been judicious and said, please only send me that one column, that's going to be way quicker, way more efficient. And networking throughput is the major bottleneck for most computing, right? Because that's slow. If you're on the same hardware, that's blazingly fast. But if you're even across campus, then you're paying for the wireless, and it's going to take a long time, right? All right. So select publisher and name from game. I don't like the name there, right? Let's look at that again. Publisher ID and name. Well, first of all, I don't like this publisher ID because it doesn't tell me who the publisher is, right? Who published GTA? All right, you know that because you played the game before. It's a famous game, right? But 6? What's 6, right? I don't like it for a second reason. Name. That was a terrible column name to select when I designed this. This is not the name of the game. What do you call those things? Title, right? So let me go ahead and rename them now for the purposes of querying. You can change the name of your column using an alias. Now this is not changing it in the database. It's only changing it with respect to the result set, also called a manifest table. Select name as game title, right? Comma, publisher ID as you can use aliases as the same thing. So publisher ID, you can go ahead and select publisher ID as publisher ID from game. And now if you look at this, now it's game title up here and publisher ID is unchanged. You don't have to use an alias if you don't want to, but using an alias now, very, very convenient if you want to rename stuff in the result set, in the result list or the manifest table. This is not a real table right here, right? This is the result of a query. So it's a table that exists in memory called a manifest table, but it's not an actual table that exists on the database. Only these tables actually exist in the database. Okay. All right, that's aliasing. What else did we do? Okay. All right. What about a where clause? Oops. You can filter your results using a where clause. Right? So, for example, for now, I'm just going to go back to the wildcard because it's easier to type. Select everything from game where I only want certain games. Say the game ID is greater than 5. Because before, what was I getting? I was getting GTA 1, 2, 3, and 4. I only want this game and all the rest. So you can use basic numerical comparisons here. And if I do that, I only get those first 4 games are not found in the result set here, or the first 5 games I think. Yeah, strictly greater than 5. And game ID is less than 10, or less than equal to 10. So you can use less than, greater than, less than, equal to, greater than or equal to, or game ID is equal to 1. Right? So this should all be familiar. The big difference is that the keywords and or are used instead of ampersands and Sheffer strokes. And then the other big difference here is you don't use an equals equals or an equals equals equals. You use a single equal sign for equality. And when you get this, then I've got 1 and then everything between 6 and 10. Right? You can also do string comparisons. Right? So select star from game where name is equal to, Katamari Damacy. Is that how you spell it? No, it is not. Damacy? Oh, okay, I've been pronouncing it and spelling it wrong for many, many years now. All right, Katamari Damacy, I guess. What does that even mean? What is Damacy? Is a mall? Oh, it's a ball.
Like Dama would be ball in Japanese, but I'm guessing that.
Dama, okay. Damacy, okay. Anyway, and here it's not, not a string comparison, not a comparator pattern or anything like that. It's a single equal sign. You can also do partial string comparisons using the string wildcard percent. Right? Select star from game where name is equal to, how about all games that start with G? Right? Double quotes here to be consistent with everything. Now this is not going to give me any results because I'm using a strict equality here. Did you notice any games that were actually G with a percent sign as their names? No. So I can't use the equal sign because that's strict equality. I want a partial string comparison, a string that looks like G percent sign. And when I do that, I get every game that starts with a capital G. Is it case sensitive? Yes, it is, because we got lucky. It all depends on how you set up the table, how you set up the column, how you inserted the data, and how you queried out the data. All four of those things can be changed so that one is case insensitive, one is case sensitive, one is Unicode, one is something else entirely. It all depends. Thankfully, the default setup on CSE is case sensitive, Latin, and so you can get some diacritics in there. Don't do it though. But it does not support, the defaults do not support Unicode. If you want to go and start putting in Japanese characters, or Katamari Damacy, whatever that is in Japanese, then you would have to change how you created that table, right? So it is case sensitive by default with the CSE setup. Right? You can use multiple wildcards. So for example, select everything from game where name like, let's go ahead and say AM, let's say. All right. That will select any game that has AM in its title, right? Which I chose that because Katamari is there. Okay, that works, but it's only one result. This will select anything with an X in the title. Okay, there's nothing. That's not useful. An R. Let's go with something more common. And then we're going to get the whole list here. All right, that'll work. How about two R's? Right. Two R's together. Nope, no results. But any two R's, you can use as many wildcards as you want. So this is any characters followed by an R, followed by any characters, followed by an R, followed by any characters. And by any, we also mean no characters at all. So when I get this, I'm going to get Super Mario Brothers, Super Mario Land, because of R and then R. Right? Super Smash Brothers, Lego Star Wars. Okay. So we're going to get, and we can use as many wildcards as you want. Okay. All right. Let's see. What else? Oh, okay. Wow. We're really good on time here. Any questions so far? No? Okay. All right, well now I want a report. Goal. Create a report with all games and their publishers. Oops. There. All right. Well, if I want a game and their publishers, I've got two different tables. What do I need to do? I want to take this table and I want to take this table and I want to shove them together because I want results from both of them. I want to join them together. Right? So to do this, to combine combine one or more tables, you need to join them together with by some criterion. Criterion, because there might be multiple criteria. All right, so select everything from game. And what I'm going to do is I'm going to join, that is a keyword, join the game table to the publisher table. All right. Now let me go ahead and execute this. This is not going to be correct, but let's see what it looks like. Whoa, I get a lot of results. All right, way too many results. There we go. GTA 4, you said that it was published by Rockstar Games, not LucasArts, not Sony, not Square Enix, not Sega, right? So what happened here for those of you that have gotten to set stuff in 235? Exactly, we did a full join here, right? We did a full, another word for this is Cartesian product or cross product or cross join if you're in the database world. It means take every element in this set and pair it up with every element over in this set. If this set is A, B, C, and this set is, let's say 1, 2, and 3, then what is this cross join here? A, comma, 1, A, comma, 2, A, comma, 3, then all the B's, B, 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 C, 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 1, 2, 3, 1, 2, 3. Right? There. We're getting a full join here. Now, if there are n elements in here and m elements over here, how many elements are there going to be in total? N times m, or we'll use n. N and n, then it's going to be n squared, right? That looks exactly like what I got here. Right? Here's another trick. So I don't know how many there were. Select count star from games, or game, sorry. 21, there were 21 records in the game table. How many publisher records were there? 13. 21 times 13 is what? Anyone?
273.
You were right. All right. Good. All right. Let me go ahead and get rid of those. And now imagine that you've got a moderately large database of 1 million records in one table, 1 million records in the second table, and you did a full join. What's going to happen? 1 million squared. What is that? Billion, trillion, quadrillion? 1 quadrillion records that are going to be returned back. Good luck waiting on that. That will take several days at least. Right? 1 million times 1 million. So that's not what we want. We want this is a full join, but it doesn't make sense because we saw that GTA 4 was published by 13 different publishers. That doesn't make any sense. The relationship between these two tables is predicated on this foreign key right here, publisher ID. They should only match up and join if this publisher ID matches this publisher ID over here. So we need to specify that. I'm going to select everything from game, join it to the publisher, but only if the publisher IDs match. On publisher ID, game.publisher ID is equal to publisher.publisher ID. Right? There. And now when I do this, I only get one record for each game corresponding to their actual publisher. GTA 4 only is going to appear here once, and it's all Rockstar Games. By the way, another trick here with most IDEs is you can resort them, right? You can manipulate them and do whatever you want here. Right? Well, that's kind of long, so I'll go ahead and put it on multiple lines here. Right, there, that looks nice. And it's also still a bit long. Game.publisher ID. Where have we seen this kind of syntax before? Dot, 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 dot everywhere. Component selection operator in C, in Java, in a lot of programming languages. Why? Because it looks neat, right? Period. That's all you need to do. All right, let's shorten this up a little bit. You can further shorten it, the query, using table aliases. So I don't want to have to write game, game, game over and over again if I'm joining to multiple things. I will rename game to G and publisher to P so that I can use those shortened aliases down here. Now this is such a common thing to do, you don't even have to use as anymore. Right? And you can get away with just that. In fact, that's usual. Game, G, publisher, P, right? Now if you had two things that started with P, then you'd have to disambiguate that. We'll see that by the end. But there we go. Well, you can join on anything that you want. You can, but likely don't want to join on anything you want. So for example, would this make sense? What if instead of the publisher ID, I joined on the game ID, matching the publisher's publisher ID? I'd get something, but does it make any sense? GTA 4 was published by LucasArts. Legend of Zelda was published by Nintendo. Okay, that works. Zelda 2 was published by Blizzard Entertainment. Right? Makes sense? Okay. Well, that's only because the game ID, 1, matches the publisher ID. You can join on whatever the heck you want. You could join on the names matching each other, right? You could join on, let's see, name is equal to the name. And those are strings, but of course I'm not going to get anything because there's no game named Blizzard. There's no publisher named Zelda, right? So you have to make queries that make sense, okay? You can, but don't likely want to do this. You wouldn't do this in a well-designed database, right? I mean, you can, but it's just nonsense data that's coming out of it, okay? That is a join. Let's join the other way. You can also, you can join in any order you want. So select, instead of going from the game to the publisher, let's go from the publisher to the game. Select star from publisher P, join game G on G dot, and we'll do it so that it makes sense. G dot publisher ID equals P dot publisher ID. All right? Let's see what we get there. Now the order is different, right? It used to be that the games are over here and the publishers are over here, but since I started with the games first and then joined them, it's a little bit different order. Okay. Let's see. Let's order this. I see. Let's count up the number of publishers we see. Capcom, Delphine, Eidos, LucasArts, Namco, Nintendo, Rockstar Games, Valve. I've got 8. All right? You've got the same count? Is that correct? Where was it? There were 13 publishers. 5 of them are missing. Why? They don't have any games associated with them. Right? These are publishers that haven't published any games yet realized by our database. And why were we getting the correct number before? We started at the child and went up to the parent. The child cannot exist without the parent. So no matter what, every record was going to have a guaranteed matching record up above because of this constraint that we've defined. But if we go in the opposite direction, start from the parent and go down to the children, well, there might not be any children. Right? So consequently, we don't get any of those records. I want those records. Right? To preserve records that have no matches, right, you can use a left join. Right? They're left inner join, left outer join. I forget what which one is which, but who cares because you don't even use those keywords. You can use those keywords if you want, but we'll shorten it up and not use it. There's a join and there's a left join. So select, here, let me go ahead and just copy paste this. Instead of a join, we'll do a left join. Run that, and guess what? Sony Entertainment, Square Enix, Sega, Blizzard Entertainment, and Atari don't have any matching games. I counted up 5, did you? That accounts for our 5 missing publishers. And when I left join on them, then even if they don't have a match, you still get they're still retained in the results, but well, they don't have a match, so null values are put in for everything that's missing. Okay. All right. Why is it called left join? And I'm going to turn around. So you start here, and then you join it to the left. Join it to the left. Join it to the left. So you might immediately ask yourself, is there such a thing as a right join? Yeah. Huh. You're just going in the opposite direction. It's not necessarily going to get you what you want. All of them are missing. Why? Because we started at the opposite direction, and we joined to the right. We joined to the right. We joined to the right instead. Right? I don't like right joins personally because that's not how I read. I read left to right. Right? Most of us will read left to right. If you think it's more natural to read, some languages do it right to left, but most of us read left to right, and so I'm only going to use left joins. If you want to, you can always use right. If you have a right join, just change the order, and you've got a left join. So there's really no reason to use a right join unless you absolutely need to. And I've got an example in the book on when you might need to use a right join. Right? If you start in the middle and you want to join something here and not lose records, and you want to join something over here and not lose records, then you need to use a right join, then a left join, if you start in the middle. And sometimes it's necessary to start in the middle. Okay? But left joins preserve records. Okay? All right, well, I said that you can join as many tables as you want. For example, select star from, again, this is something janky that you would not want to do, from game, join game, there we go, on game ID. Let's do it like that. Will you let me do that? No. Game G1, G2, G1.gameID is equal to G2.gameID. Hopefully this, okay, there we go. What did I get? 22? Only 22 records? That seems, oh, no, I don't want an on clause then. Why won't you let me do that? There we go. That's what, I was only getting the games themselves in double copies everywhere because I was joining the game ID equal to game ID. But now how many am I going to get here? Do you remember how many games were there? 20, 21? So 21 squared is going to be 4 something. I don't know. Say what? 441. Okay. Did you do that in your head?
No.
Oh, okay. 441. Then your calculator's not broken. Right? You can join as many times as you want. Of course, what's the point of this? You wouldn't want to do something like that. So what I want to do is I want to flatten out the entire data model. What I want to do is I want to take the game and join it to the publisher, then join it all the way to the platform. Now, to go from the game to the platform, what am I going to have to do? Is there a direct connection between those two tables? Nope. I'm going to have to go through the intermediate table called availability. So I'm going to have to join the game to the availability table, and then the availability table I'm going to have to join back up to the platform. Okay? That's going to require several joins. Yeah, so let's do that. You can join as many tables, select, where should we start? Oh, that's a good question. Where should we start? Select everything from game G, join publisher P on G.publisher ID is equal to G.publisher ID. Okay. Then join again to availability A on how are these two tables related? You look in the child table, see game ID refers back to this primary key over here. Foreign keys generally refer to primary keys. All right? On A.gameID equals to G.gameID, join platform ID or platform P on a.platform ID equal to p.platform ID. But of course, what's going to happen here? I've got two aliases with the name P. So I'm going to have to disambiguate that and say pub instead of P, pub. And now I will get this, get all these records. Right? That Lego Star Wars was published by LucasArts, and it's available on Xbox. And what else? Oh, nothing else? Let's go ahead and sort them. Whoa, GTA. Why am I getting so many duplicate records? What did I screwed something up. Game G, join publisher P, GP, availability A on game ID is equal to g.gameID. Join publisher pub on platform ID equal to pub. I don't see anything wrong. Where is it? Thank you. Yes, there we go. Good eyes. G.publisher ID, P.publisher ID. There we go. There, now that makes sense. Right? And GTA 4 was published by Rockstar Games, but it was available on two systems, PC and Xbox. Okay, Xbox 360 it looks like. Lego Star Wars was published by LucasArts, but it's available on 4 platforms, Xbox, PlayStation 2, PC, and Mac. Is that true? Okay. Well, with emulators, anything is possible. All right. So did I get all the records, though? First of all, what do you see here? Lots of repetition, because anytime you join, you're going to get 2 copies of that data. So maybe as a last thing for today, let's go ahead and get what you originally had in your first assignment, a fully flattened data model. I want the games, or the publisher's pub's name as publisher name. Right? What else do I want? I want the g.name as publisher title. What else do we want? A.release year as release year. And finally, what do we want? Platform. Platform. Oh, wait, did I call it pub down here? I called platform pub. Maybe that was my confusion. PL, maybe, and PL. There. And this should be P. And PL.name as platform. Platform. There. Good enough. Oh, no. A.release year. Oh, what is it? Publish year. Okay. Publish year. But I'll go ahead and put in the alias as release year. And there is your data model that you used. In fact, I think that's actually the exact same data in the handout that was used in your first assignment. Right? Just CSV data instead. Except for it doesn't look exactly right. What do you see that's missing? Or what was in your assignment that's clearly not here? Missing data. Why was that? I used joins. Right? So if I start at the game, and I want to still get every publisher that exists, even if they don't have any games published, what do I need to do? A left join, okay. Except that, how should I join it? If I start in the middle, game, and I want to join publisher over here, what side is it going to be on if I'm going to preserve records? It's going to be joined, it's going to be on the left side, but it's joined on the right. So let's go with a right join. And, nope, dang it, I screwed up somehow. A left join. Should be like this. Okay, start at the publisher maybe then. Publisher, P. There we go. That, then left join, game, G. That'll preserve all the publishers. No? Left join. What am I doing wrong? start at the publishers, left join game. I don't see any problem here. Left join on g.publisher_id. Okay. Does anybody see what's wrong? I'm going to have to take a look at this, but we don't have time. So let's just go left join, left join, left join, and see what we get. There we go. Oh, that's right. If you left join and then you do a regular join and a regular join, guess what? You lose everything that had a null in here to begin with. And so I was not going. I was thinking I could do this piecemeal for demonstration purposes, but no, you can't. Left join, left join, left join everywhere, and that is the data that you had. Not necessarily in that order, but that's the data that you had for your first assignment. That some publishers don't have any games. Some games are not available on any systems. For that, do we have any games with publishers that are not available on any systems? Where? Oh, here, GTA 3 is not available on any systems, but you're guaranteed to have a publisher. Some publishers don't have any games, but every game has a publisher. So there's the actual data that I think was in the handout that I've been using for years. All right. Any questions? No? Then we will continue with